Hello, welcome you all in the 1 week faculty development program in blended learning and pedagogical techniques organized by St. Judas College, Thutur, Tamil Nadu in collaboration with Teaching Learning Center, Ramanujan College, University of Delhi under Pandit Madan Mohan Malviya National Mission on Teachers and Teaching Scheme. Myself, Dr. Umesh Sanpa, working as assistant professor in the Department of Chemistry, Gokhale College, Ratnagiri, Maharashtra. My institute is affiliated to the Mumbai University, Mumbai, and re-accredited in the 4th cycle by NAC Bengaluru with A grade, having a CGPA of 3.22. Our institute is awarded by Best College by University of Mumbai in the year of 2007-8 and having a status of UGC college with potential for excellence. Our science faculty is sponsored by DST FIST, and today I am going to discuss a small part of chemistry is occurrence and extraction of lanthanoids, which is also called as lanthanones. This part deals with the importance of lanthanoids, what are their exact applications in different fields in concern with their domestic as well as industrial point of view, and what are their exact occurrences, in which state they are exist in the nature, which are their major sources, and how it is to be get extracted from their respective ores. These all parts will be discussing. These are the different applications of the lanthanoids. Lanthanoids can be used in the form of their ions, their elemental form, as well as a mixture of elements in a different equipments or some devices. Okay, this is their major applications are they are being used as energy productions or energy reductions, as in a solar cell. Or they can use in like LEDs, LCDs in petroleum refineries, UV filters. So these compounds has a huge number of applications in our domestic as well as industrial life. Okay, and this data reveals that the applicability of these lanthanoids or their compounds in our domestic as well as industrial. This part is deals with the occurrence of the lanthanoids, means what the existence of the lanthanoids in the nature or in the rare earth. Okay, as we know that all the lanthanoids are exist in the rare earth in the combined state, and the basic reason behind is there is very small change in their ionic radii. Means what, all 15 lanthanoids except promethium, because of its radioactivity, all the remaining 14 lanthanoids are exist in the combined state, and the basic reason is there is a small change in their ionic radii, and this is because of the lanthanoid contraction. If you go to this diagram, you can judge that there is very small change in their ionic radii. The first element, lanthanum, has an ionic radii of 1.216 angstrom unit, while that of last one, lutetium, is a 1.032 angstrom unit. Means there is very small change in their ionic radii. Basically all the lanthanoids have a common oxidation state of +3. Broadly, these lanthanoids are classified into the two types. One is called as lighter lanthanoids, in which lanthanum, cerium, praseodymium, neodymium, samarium, europium and gadolinium are inculcated, while that of heavier lanthanoids are gadolinium, terbium, dysprosium, holmium, iridium, terbium, ytterbium, lutetium and yttrium. These are the different sources or occurrence of the lanthanoids. As we know that broadly there are total 160 minerals of the lanthanoids, in which the lanthanoids are exist in the rare earth. Out of that, basnasite, monazite, gadolinite, cerite, laterite clays and loparite, these are the major minerals of the lanthanoids, and out of that basnasite and monazite or the gadolinite or cerite, in which the content of lanthanum is been in a sufficient amount through which we can extract that lanthanoids in a quantitative manner. These lanthanoids are exist in a different forms, and based upon that they are being classified as a Basnasite, in which the lanthanides are exist in fluorocarbonate forms, in which the content of the lanthanides is about 50%, while that of monazite are exist in the orthophosphate, means what, they are exist in the form of lanthanum phosphates, in which the lanthanides is about 50 to 78%, and the major content of this ore is thoria, is about 12% of the thoria, and traces amount of iron, silicon, titanium, zirconium, etc. That is some transition elements. Gadolinite is a silicate form of the lanthanides, which contains near about 10 to 17% of the lanthanides, with the barium oxide and traces amount of the some transition metals, and some non-transition elements like also calcium also. Cerite, in which the lanthanides are exist in the form of silicates having 71% of lanthanides, and a certain amount of traces amount of the iron as well as a. Before we discuss the exact extraction process used in the extraction of lanthanides, just we go through thoroughly the history of extraction process for the lanthanides. Here in the 1980, almost 40% of the world production of lanthanides from monazite ore, but after 25 to 30 years, that is into 2010, a very small fraction of the lanthanide productions were taken from monazite ore. That is because the monazite ore contains thoria, that is nothing but the thorium oxide, and in this thorium oxide, the thorium is a radioactive elements, so their handling storage is one of the major problem, and the second one is nothing but their economy, because the economic cost to separate the lanthanides from monazite is somewhat higher as compared to the basnasite. So after that, the lanthanides were separated from the basnasite ores, but in the next 2-3 years, that is in 2014, all these drawbacks, that is nothing but the handling as well as the storage of monazite ore concerned to their radioactive elements as well as their economy. One foolproof method is being developed by Australia, and which is one of the major highlight to extract the lanthanides from monazite ore. So as we discussed about the two different minerals, that is one basnasite and second is nothing but the monazite. Out of that, here we are going to discuss how the lanthanides is to be get extracted from the basnasite ore. Basically, this basnasite ore, they are exist in the form of like lumps. So initially it is been grounded to convert into the fine powder of a specific mesh size, and second step is nothing but the concentration, means what, you have to remove the impurities. The concentration of the ores is being carried out by different method like magnetic separation, froth flotation, but out of that the froth flotation technique is being used over here, in which the barium and strontium is being get separated out in the form of residue, while the froth of lanthanum will be get separated out in other side. So in this case, the lanthanides which is almost 10 to 15% has been converted into 60%. So that is nothing but the concentration of the ore. And in the second step, it has been treated with a 10% of the hydrochloric acid, in which the calcium carbonate is to be get calcium, which is the impurity, is converted into the calcium carbonate, and it's dissolved in a hydrochloric acid, and it has been get separated out by simple filtration, and the remaining part is nothing but the residue which are exist in the form of lanthanum oxide. So in this treatment, it is also part of concentration in which the lanthanides is get concentrated from 60% to the almost 70%. Okay. Afterwards, as we know that the lanthanides, this is a mixture of a different lanthanides except promethium, and they are exist in a different state. their stability is in a different oxidation state. So here the first part is nothing but the roasting. As we know that all the lanthanides have a common oxidation state of +3, but rather than this one, they are exist also in a different oxidation state, they are +2 as well as a +4. That is nothing but to achieve their nearest noble electronic configuration. So in this case we follow the roasting. So this residue of lanthanum oxide is to be get roasted, means this is a process of oxidation in which the cerium is been converted from +3 to the +4 oxidation state in the form of oxide, and can be separated out very easily. And the remaining part is been get cooled and leached with HCl, in which except cerium, which is been get separated out in the form of residue, it is been converted into lanthanum oxide to the lanthanum chloride in aqueous phase. So we got lanthanoids in the form of aqueous phase as a lanthanum chlorides, and in a similar fashion as like oxidation, that cerium convert from +3 to the +4. Here we go for the reduction, in which the europium from +3 to get reduced in the +2, we got the europium oxide, and the remaining lanthanides to be get separate out by different techniques. For the same, there are different separation technique like a solvent extraction, ion exchange, fractional crystallization, fractional precipitation, or fractional thermal decomposition. Now the next part is nothing but the extraction of lanthanides from monazite ore. In the first part we have to collect the monazite ore, and it is to be grounded in a fine powder or sand of a specific mesh size. Basically the monazite ore are exist in the phosphate form, lanthanum phosphate, in which the major impurity is nothing but the thoria and the traces amount of some transition elements. Okay, that's we are well familiar with that. This thoria is a radioactive element, hence the their handling as well as the storage is one of the major challenge during the extraction of lanthanides from monazite. So the first step is nothing but the digestion, and the digestion of this monazite ore is carried out with the help of a concentrated sulfuric acid at about 200 degrees centigrade. In this step this monazite ore is been converted from this fine powder or sand to the pasty mass, in which this lanthanum which are exist in the phosphate form is been converted into the sulfate form because of the sulfuric acid, along with the phosphoric acid and a residue of silica and zirconia. Then this mass, pasty mass, has been filtered and we got aqueous solution of lanthanum sulfate along with the thorium and phosphoric acid in the form of solution, while the residue of this silicon and zirconia is bit get separated out. So this is nothing but the concentration process, in which the residue of silicon and zirconia is been get separate out. Okay, in this step this lanthanum sulfate having a pH is very low. So after dilution with the cold water, the pH is to be get adjusted up to the 7 or just a 7 to 8, in which the residue of thorium is being converted into the thorium phosphate, and which can be separated out, and the remaining part is nothing but the aqueous solution of lanthanum in the form of sulfate, which contains a different lanthanoids except promethium, which is to be get separate out with the help of different techniques, that is nothing but the solvent extraction, ion exchange, fractional crystallization, fractional precipitation, fractional thermal decomposition, etc. In this extraction process we are going to discuss the extraction of lanthanoids in a basic condition. Before that we discussed, or in the previous slide we discussed how the lanthanoids were extracted in acidic condition with the help of a sulfuric acid in a digestion process. Now we are going to discuss how the lanthanoids were extracted from monazite ore in a basic condition. The first step is that the digestion. Here the digestion were carried out with the help of 70% of sodium hydroxide at about 150 degrees centigrade, which in a oven. This process has been carried out in oven for several hours. So what happens, this lanthanum phosphate react with the sodium hydroxide, and the lanthanones are converted from lanthanum phosphate to the lanthanum hydroxide along with the thoria. So they are being converted from lanthanum phosphate to the lanthanum hydroxide, and after digestion they are get separated by the simple filtration technique, in which they separate out aqueous solution of sodium phosphate while the residue in the form of lanthanum hydroxide and thoria. Now this lanthanum hydroxide and thoria is treated with a concentrated hydrochloric acid at about the pH of 3. So in this case the lanthanum hydroxide treated with HCl, in which initially the HCl will neutralize this lanthanum hydroxide, and afterwards this lanthanum react with hydrochloric acid to form the lanthanum chlorides, while this thoria react with its hydroxides to form the thorium tetrahydroxide in the form of residue. So this they can be separated out very easily. So this thoria is separate out in the form of thorium tetrahydroxide, while the lanthanum react with this hydrochloric acid to form the lanthanum chlorides in the aqueous phase, and afterwards these lanthanum chlorides can separate out with the help of a solvent extraction technique, in which we can separate out each lanthanides in very simple. And thank you very much.